hope you are doing well. In this video, we would be discussing about the problem named Alice Tour. Firstly, we will go through the problem. We will see what the problem is expecting from us, what are the constraints for the problem, discuss the approach for this problem, and after that, we would be discussing the implementation as well as the code for this particular problem, right? So let's just move forward and see what the problem says. Problem statement says that Alice is standing on a grid having infinitely many rows and columns. So basically, it is not given in the question that how many rows and columns would be there. You are supposed to assume that there would be infinitely many rows and columns, right? Now the next is each cell of the grid that we are denoting by I comma j, where I is row and j is column, contains a number I into j, right? That means I is multiplied by j is initially would be stored in every cell of the grid, right? Then initially Alice is standing on a cell 0 comma 0, that is your origin, right, for the grid. In one move, Alice can go to any adjacent cell to her current cell, right? That is, if Alice is standing on cell I comma j, then in one move, Alice can go in either of the cell I plus 1 comma j, that would be the cell just downwards to current cell. Then I minus 1 comma j, that would be the cell just on top of it. I comma j plus 1, that would be its right cell, and I comma j minus 1, that would be its left cell. So basically, Alice can move to any adjacent cell from top down, left and right. Okay. So the next is that Alice gives you a number n, and you have to tell what is the minimum number of moves Alice needs to go from 0 comma 0 to any cell in which number n is written, right? So basically, you need to find the nearest cell to the origin which would be having the number n in it, right? And here we have the constraints. Your number of go to first column, second column, third column, and then ultimately it would, and you where your I is row number would be a single integer t, that is your number of test cases, and each test case contain a single integer, that is the value of n, right? And in your output format, you have to print the minimum number of moves that Alice can make to go from origin to the cell at which number n is written, right? So now let's just move forward and see how we can solve this problem. Here I have taken a random grid as it was given in the question that there would be an infinite grid, right? As it was given in the question that at any cell I comma j, where your I is row number and j is column number, the value which would be stored at this particular cell would be equals to I into j, right? And your whole grid would be filled where every cell would be storing a number as I multiplied by j, right? Now let's take any random cell. So for example, if we are taking this particular cell, what should be the value at this cell? So here you can see your row number is 5 and your column number is 4, right? So if we describe it in terms of I and j, the value of your I would be equals to 5 and your value of j, that is your column number, would be 4. So number that should be stored here would be 5 into 4, which is basically equals to 20, right? So similarly, at every cell a number would be stored, which would be the multiplication of row number and column number. Simple. Now the second thing is that, let's say if we have any cell given, so let's say we have this particular cell. So what should be the number stored at this particular cell? So here you can see the row number is 6 and your column number is -7. So this is your I and -7 is your column number, that is your j. So 6 multiplied by -7, which would give you -42. So here the number that should be stored would be 42, right? So this was the first thing that we have seen, that at any cell I comma j, what would be the number stored at that cell. Now let's see the next thing, which is number of moves we need to reach a cell I comma j from origin, right? As it was given in the question that we need to reach a cell from origin. So let's see how we can find the number of moves that we need to reach a cell I comma j starting from the origin, right? Now, if we will calculate the number of moves required to reach at this particular cell, So let's see how many moves we have. So firstly, user would be here at 0 comma 0, your origin, right? So the next thing is that it wants to reach at this cell. So firstly, it would move through the 0th column and would reach at row 5, and then it would go to first column, second column, third column, and then ultimately it would reach at the fourth column, right? So how many moves it have taken? So you can see 1, 2, 3, 4, 5, that is equals to your number of rows. Then 1, 2, 3, 4, that is equals to your number of columns. So total moves that was taken was 5 plus 4, which is equals to 9. Now let's see if it would take some other path, then how many moves would be there, right? So if it would be taking this path, that firstly it would go here at column 1, then at column 2, then at column 3, then at column 4. After that, it would be moving to first row, second row, third row, fourth row, and then your ultimate fifth row. So what it would be? So here you can see in the zeroth row, it have covered 4 columns, and then in your fourth column, it have covered 5 rows. So it would also be 4 plus 5, which is equals to 9. So total steps that are taken are 9. Even if you would take any path like this, ultimately your number of moves would always be equals to your number of rows plus number of columns, because ultimately the distance that you are covering is equals to your number of rows plus number of columns, right? So here we can say, to find the minimum number of moves to reach from origin to your cell, they would be your I plus j, right? Minimum number of moves to reach a cell I comma j from origin would be I plus j. Cool. Now similarly, if you will see the number of moves for this cell, you can see here also Firstly, let's say if we will traverse through this 0th row, there would be 7 columns, and then in your 7th column there would be 6 rows. So 6 plus 7 would give you 13. So total number of moves that we would be making to reach at this particular cell would be 13, right? So you can take any way and you would get the same number of minimum moves to reach at a particular cell I comma j, right? So we have seen two things. That first is what number would be stored at a particular cell. Second is minimum number of moves that we would be needing to reach a particular cell I comma j from the origin, right? Now the next thing given in the question is that there would be a number n, and you have to find the minimum number of moves to reach a cell which is containing this number n, right? So let's see it through an example. So till now we have seen every cell I comma j stores a value equals to I multiplied by j, right? And next thing that we have seen is minimum moves to reach cell I comma j
और आजाद लोग
from origin
अच्छा ठीक दुकान में तेरे बोलता है
would be equals to I plus j, right? Simple. Now let's see if we have given a number n, for example, its value is 12, then how we can find the minimum number of moves that we need to reach a cell which is having the value 12, right? So firstly, let's see for which all the cells the value stored would be 12. So as we know, I multiplied by j is stored in the cell. So there would be some I into j's which would give you as 12. So let's just see what combination of I and j can give you 12. Let's do the factorization. So 1 into 12 can give you 12. Then 2 into 6 can also give you 12. Then 3 into 4 can also give you 12. Then 4 into 3 can also give you a 12. Then if you will move forward, then again 6 into 2 can also give you a 12. And again 12 into 2, sorry, 12 into 1 can also give you a 12. Now if you would see carefully, like after this particular point, your factor started repeating. Like I comma j become j comma I, right? So we can consider only the first half. How we will determine that where this first half occurs, after which particular point your factors start repeating? If you will observe carefully, your factors are starting repeating after square root of your number n. So for example, let me give you the another example. If you have number 16, so if we will write the factors of it, it would be 1 into 16 is equals to 16. Then 2 into 8 is equals to 16. 4 into 4 is equals to 16. 8 into 2 is equals to 16. And then again 16 into 1 is equals to 16. Right? So here you can observe directly that after this point, when your square root occurred, the factors started repeating, right? Your I into j became j into I. Simple. So let me just erase it. So now, as we have seen that we can achieve 12 in all these ways, right? So let's see. Firstly, we can have your 12 here at this particular point where your where this point is 1 comma 12, right? As 1 into 12 would give you the value 12. Then let's check out this next point, that is 2 comma 6. So here this point would also give you, this cell would also give you the value 12, that is 2 comma 6. Then your next is 3 comma 4 is equals to 12. So basically this third row and fourth column cell would also give you the value 12. Now next is this 4 comma 3. So here your fourth column and third row would also give you the same value, just 4 comma 3, 12. 6 comma 2 is equals to 12. So here your sixth row and second column, this is also giving you 12. And last is your 12 comma 1. So this particular cell at 12 comma 1 would also give you the value 12, right? So these are all the cells. These are all the cells which would give you the number 12. Now the similar combinations can be of your negative also. That for example, minus 1 into minus 12 would also give you 12. Minus 2 into minus 6 would also give you 12. Similarly, minus 3 into minus 4 would also give you 12, and this would go on, right? So here at this particular point you can get 12. Similarly, at here you can get 12. Here also you can get 12, right? And here at minus 12 comma minus 1 you can get a 12. Then at 6 comma 2, at minus 6 comma minus 2 you can get a 12. And apart from this, at row 2 and column 6 also you can get a 12 here, right? So this is also would be your 12, right? All these values would also give you 12. Simple. So now, as all these cells are having the number 12, what we need to do is we need to find the minimum moves to reach a cell I comma j. So as we know, the minimum number of moves to reach at a cell I comma j would be I plus j, right? So by using factorization, we have determined all the cells at which 12 would occur. Now we need to find the nearest one. So now, if you will see how much moves this first one requires. So here I is 1 and j is 12. That means this cell. So number of moves to reach at this cell would be, we would start from here. We would firstly go to at this particular cell in first row, and then we will go to a 12th column. So there would be 1 plus 12, that would be 13 moves, right? Or otherwise you can go at this way also, that you will firstly go to the 12th column in 0th row and then at the first row. So there, by that way also there would be 12 plus 1, there would be 13 moves. As we know, it would always be I plus j. So for this particular cell there would be 13 moves, right? Now let's see for the next cell, which is 2 into 6. So that is 2 comma 6. This particular cell, the number of moves to reach at this cell would be 2 plus 6, that is 8. So we can reach here in 8 moves. Similarly, here it is 3 into 4. So here we can reach in 3 plus 4 moves, that would be 7, right? So here we can reach in 7 moves. Now here again at 4 into 3, this 4 comma 3, 4 plus 3 would be 7. So we can reach here in 7 moves. Then 6 plus 2, it would give us 8. So here also we can reach in 8 moves. Then 12 comma 1, which would give you 12 plus 1, that is 13. So here we can reach in 13 moves. So 13 moves for this one, right? Now as you can see, when we are multiplying I comma j, after the square root of n, factors are repeating. So we can ignore the later on part, because I comma j is just reversing as j comma I, which is not affecting our number of moves. We have already got these moves, that there can be a possible cell with 13 moves, there can be a possible cell with 8 moves, and there can be a possible cell with 7 moves. Same thing we are getting again. So there is no point of getting them again and again, right? So what we will do, we will just consider the cells which are there before your square root of n, right? So that we can get all the unique values. Now, if we will consider the number of moves for these negatives also, like minus 1 into minus 12, so there would be also the same number of moves, because moves can't be negative, right? You can't say there are minus 13 moves, right? Moves would always be positive. So we will just take mod of it. So that would be 13 moves here. Then 6 plus 2, it would give you 8. 3 plus 4, it would give you 7. The numbers would be similar as your positive ones, right? So now the next thing is you need to find the minimum of all these moves, that is 7, 8, and 13. So as we know, 7 is the minimum one. So we can say that to reach a cell which is containing 12, the minimum number of moves would be 7, right? Simple. So guys, I hope this explanation clears you the question that firstly we have seen at a cell I comma j, the number stored would be I multiplied by j. Then minimum number of moves to reach at a cell I comma j from origin would always be I plus j, right? Now for a number, if we need to find the minimum ways, then firstly we need to find all the occurrences of it, that at which particular cell this number is occurring, and we have done that by factorization, and we have seen that there is no point of moving after the square root of n because factors just gets duplicated after that, right? So this is how we can find all the factors till root n and get their sum to find our number of moves. After that, we can just have the minimum number among all of them, right? So let's just see how we can implement it in our code, and after that, we will just see a small optimization of it also, right? So let's just see how we can code. So here, let's just code this problem. So let's say you would be given a number n. For example, let's take it 12 for now. And let's implement a function minimum moves. Here we would pass our n. Now let's write this function minimum moves. Let's just write function minimum moves in which we would be getting a variable n. So let's say initially the minimum moves that we have is equals to infinity, because we don't know that what would be our minimum number of moves. We need to compare it further. Now the next is, as we have seen earlier, we can find the factors of your n to find your I comma j, right? So let's say, so as we know, we would be traversing from 1 to square root of n, because after that your factors start repeating. So let your I starts from 1. We won't be starting your I from 0, because 0 multiplied by something would always result into 0, right? So you would never be able to reach to n in 0th row or 0th column, right? So then your I would be smaller than equals to math dot square root of n. As we know, we will go till the square root of n, and then your I plus plus. And every time what we are going to do, we will check if I is a factor of n. So if n modulo by I gives us 0, that means I is a factor of n. And if I is a factor of n, then we can find our j also, that for this particular I, what is corresponding j. So let j for this particular case would be equals to your n divided by I. Simple. And as you have now your I and j of a particular cell, you can get your moves. So let current moves, which is basically the number of moves to reach your current cell I comma j. So it would be equals to I plus j, right? Then as we need to find the minimum number of moves, so every time you will need to update your minimum moves if your current moves are less than your already found minimum moves. So we can just check if your minimum moves till now is greater than your current number of moves. Then what you can do is you can update your minimum moves with current moves, right? That is the moves to reach your current cell. Simple. At the end, when this loop will end, we will get our minimum number of moves, and we can return here our minimum moves, right? So here, when we are calling the function, let's say we are getting the moves. So let moves So at the end, when we are calling this function, we would be getting the number of moves. So let moves is equals to minimum moves of n, and let's just console.log the moves. Now let's just see how we can run this particular file. So new terminal, and let's run it. There you can see answer is 7. So we are good, right? We were expecting the answer as 7. So what we have done here, let's have a quick go through. Firstly, we have taken the minimum moves as infinity because we can't take a minimum number to compare, right? Otherwise, how we will get the minimum one? Then we are starting your I to move from 1 till square root of n to get the factors of n. So whenever we will get a factor of n, which is I, we will get the another factor also, which would be j. And after finding I and j, we will find that to reach the cell I comma j, how many moves we need. And if these current moves are less than the minimum moves that we have found till now, we will just update our minimum moves with your current moves, right? And at the end, you can return minimum number of moves that you have found. Simple. Now let's just see a small optimization of it. So here we have seen earlier that, so here let me clear the clutter a bit so that we would be able to see. Here, this was your I, which we have started from 1 and we have gone till your under root of 12. So under root of 12 would be 3 point something. So we will go till 3 for the value of I, right? And when we will do 12 divided by 3, we will get 4. Similarly, when we will do 12 divided by 2, we will get 6. So that is how we are getting your j also with the help of I, right? Now the point is to find the minimum. We are going from 1 to your square root of n. So we are going from 1 to the square root of n. Is that needed? Do we actually need to iterate through all the numbers? So if you will observe here, the numbers, or you can say the factors at the starting are far away, right? So their values giving us a bigger sum. Here you can see 1 plus 12 would be your 13. 2 plus 6 would be your 8. 3 plus 4 would be giving you 7. So, as you will keep moving towards the square root of n, you will keep getting lower values, and minimum of them would be the one which is closest to your square root, right? So, here that was your 3 and 4. Now, let's just see it through one more example also. So, if we are doing the factorization of 16, if it would be 1 into 16, 2 into 8, then 4 into 4 16, then you're again 8 into 2 16, then 2 into 1 3, right? These are all the values you will get. Now here you can see 1 into 16 was 16, so here the value is 17. Their sum is 17. 2 plus 8 is 10. 4 plus 4 is 8. So this 4 into 4 is its square root, or we can say it is the value which is most near to the square root, right? So in that case we can say the value which would be the most nearest to your square root would be your answer, right? So the point is, instead of reversing from 1 to square root of n, like here from 1 to 3 and here from 1 to 4, instead of traversing from 1 to 4 for the value of I, what you can do,
कुछ नहीं
would it will give you the minimum sum. So for example, in the case of 12, the square root of 12 would be 3. So if we will start from 3, so 3 into 4 would be giving you 12. So as soon as you will find that 3 into 4 is giving you 12, so we will know as we are starting from square root of n, so the first factors we will get as a pair of I comma j will give us the minimum value right? That is 7 here. And we don't need to traverse till 1. We don't need to traverse till 1 from square root of n, right? From square root of n, we will just say, okay, let's find out a first factor, whatever we are finding, and then we can just return from there. We don't need to go till 1, because we know that if we are starting from square root of n, the first factor that we will find will give you the minimum sum, right? So let's just implement this optimization in our code as well. So let's implement it the as optimized version. So I'm making it as minimum moves optimized, right? And here, instead of starting from 1, what I was saying, I can start from mat dot square root of n. Till where we can go? Till greater than or equals to 1. And every time as we are decreasing the numbers, we will do minus minus, right? And everything else would remain same, that we are finding the first factor, and then as soon as we will find our first factor, we will just return it. So here, instead, we don't need this comparison and all. What we will do, as soon as we will find your first factor, right? We will just say, okay, we have found the minimum moves. We know it would be minimum moves, and we can just assign the value as current moves to it and break our loop. We don't need to go further. We have already find our minimum moves. At the end, you can just return your minimum moves. Right? So here we have put the break statement so that we won't go further in the loop. We will break as soon as we will get the first factor.